we would like to simplify the expressions for parts A and B. And basically what this is pattern recognition. So let's look at part A. Do you see how that says cosine squared of 7x minus sine squared of 7x? Yes?
Yes.
Study your double angle formulas and tell me which one that looks the most like. It looks the most like the first one, so cosine of 2a equals cosine squared of 1a minus sine squared of 1a. Does that make sense? So basically, what you were given here looks like the right side of that. Does that make sense? Okay. In order for this to be the right side, what does the left side have to be? It has to be cosine of what? For that to be true. It has to be cosine of double that angle. So if the angle is 7x on the right side, then the left side has to be 14x. That's what you're being asked to do in these types of problems.
That's easy.
For most people, if you recognize the patterns, it's pretty easy. Do y'all understand that? Okay. So they're going to give you a piece of one of the identities, and you're going to have to use the other side to simplify it down.
I got you.
This is the hard one. This is the one people miss all the time. Okay? Because it doesn't look exactly like one of them. Okay? Now it looks a lot like sine of 2a equals 2 sine of a cosine of a, right? But it's missing the 2. But this is an equation, and as long as we're not verifying, we are allowed to move things from one side to the other. So what we could do is we could take this 2 and we could move it to the other side. So we could rewrite this identity by dividing both sides by 2. So now the identity says that sine of a cosine of a equals sine of 2a over 2. And here's what I want to make sure you understand. This over here, this side, does not simplify to sine of a. You can't cancel an angle. It doesn't work. The angles are they're untouchable. The only way you can change an angle is by using the left or right side of an identity. You cannot change an angle by just dividing by something. Does that make sense? So I know
2 sine a over 2, because you cancel it then.
if the 2 is out here in front,
That's
yes.
yes.
Yes. But you can't cancel from in here. This is untouchable. So be really careful about that.
How did you move the cosine to the other side?
I did it. I just wrote it right side first without thinking. I don't know why. Okay. All right. Do y'all see that? So now this matches this. Do y'all understand that? Okay. So that's what I have. I have sine of 15, cosine of 15. And that has to equal this. So that has to equal sine of double the angle, so sine of 30, and whatever that is divided by 2. Okay? Well, what is the sine of 30? And guys, you cannot cancel this to 15. It doesn't work. Since it's on our unit circle, we keep going. The sine of 30 is 1/2. So really this is 1/2 divided by 2, which is 1/4. So it's a little bit harder when they don't match exactly, but what you do is you go and you rearrange the identity that you're using before you start, and you make it match exactly. Does that make sense? Yes? No? Maybe?
Yeah, let's go to the next problem.
Okay. All right, the next problem's going to be a little weird, so just kind of bear with me, okay? So hang on, let me pause for a second.
Save a horse.
All right, final example, you guys. If I want to write the sine of 3x in terms of sine of x, that's what it says to do. And in and of itself, this is kind of a weird problem, but it's neat because some of the concepts can be used if you're trying to verify. So that's the only reason we're doing it. Also, do we have an identity for sine of 3x?
Nope.
We only have an identity for sine of 2x, right? But do we agree that 2x plus 1x is 3x? Yes? So if I start with sine of 3x, we know that sine of 3x is equal to sine of 2x plus 1x. Agree? Well, that looks like sine of a plus b. So I could use my sum identity for sine and expand that out and say that this equals sine of the first times cosine of the second
Plus cosine of the first, sine of the second.
plus cosine of the first times sine of the second. Good job. Okay, all right. Once I get to there, I can use my double angle identity to get rid of the sine of 2x. Because see, it wants us to get it all into sines of plane x. Does that make sense? Okay, so we're going to substitute in, instead of the sine of 2x, what can I replace that with?
2 sine A.
So 2 sine of x, cosine of x, and then I already have another cosine multiplied. All right, now here's where we need to be really careful. If I want to expand out cosine of 2x and get rid of the 2x, I have 3 options. But this problem does not want me to have cosines in the end. It wants me to have sines. So choose that third option. Choose 1 minus 2 sine squared of x. So we're going to replace this piece right here with 1 minus 2 sine squared of x. And then it's all multiplied by a sine of x. So we're going to clean it up. It's okay. We're going to make it. We can do it. We will persevere. The first term right here becomes 2 sine of x. And this makes me happy. That's what we want. We want a bunch of sines of x. And this makes cosine squared. So that's a little upsetting because it doesn't say anything about cosines. It wants you to have all sines. Then over here, I'm going to distribute the sine of x into this parenthesis. I'm going to multiply there and here. Y'all understand that? Okay. So it's going to be plus 1 sine of x minus 2 sine to the what? Third, yes. 2 sine to the third of x. Okay. So technically, everything's fine. This is a sine of x, this is a sine of x, and technically this is sine x times sine x times sine x. And so that's legal as well. I need to figure out a way to get rid of this cosine.
Can you use the Pythagorean identity?
That's a wonderful idea. We could use the Pythagorean identity to replace the cosine squared with 1 minus sine squared. So we'll go back and use the Pythagorean identity and change the cosine squared to 1 minus sine squared. Think it's a lot of work? Well, you know,
Is there more?
we have the same number of minutes every day. We may as well, you know, do some problems. All right. So 2 sine times 1 is 2 sine x minus 2 sine cubed x plus sine of x minus 2 sine cubed of x. For a total of 3 sines of x, right? 3 sines of x minus 4 sine cubed. Okay, so here's what you guys have done. We started with sine of 3x. We had no idea what it equaled, and we actually made a formula for it. So if you wanted to memorize that, you could now know forever that sine of 3x will always equal 3 times the sine of 1x minus 4 times the sine cubed of that x. Isn't that neat?
Wait.
Okay, well, I thought it was fun.